So we've talked about the properties of a triangle, and we've talked about the properties of a quadrilateral. Now it's time to talk about the properties of a circle. We have 4 properties here, but to be honest with you, we could have really done with 3. But you know what? Let's just jump straight into it. Oh, sorry. Before we jump into it, there are many properties of the circle that we are not going to talk about. We're only focusing on a few. Okay, there's a lot of things you can talk about when we talk about this beautiful shape, but I'll just mention 4 of these properties. Okay, so let's start off with something that's pretty straightforward. Okay, I'm gonna draw. Okay, so what have I drawn? Hopefully you can all agree that this is the diameter of the circle. And one thing you have to understand, diameter of a circle, let's say diameters of a circle intersect at the intersect at center of circle. So I should have drawn another diameter. Let's see. You can draw more, but no matter how many diameters you draw, you'll realize that every single one of them has to go through the center of the circle. Okay, and that makes sense because otherwise the line segment that you draw will not be the longest possible line segment if it doesn't go through the center of the circle. And that's what the diameter really is. It's the longest possible line segment you can draw within this this circle. Okay, so yeah, to be honest with you, it's pretty straightforward. Not much to say about this. You could have really established this when you first learned about a circle. Diameters of a circle intersect at center of the circle. Right, so let's do another one. Ooh, right bisector. We're gonna draw a right bisector. So first, we're gonna draw a chord. Okay, what is a chord? Well, you actually know what a chord is. A diameter is a chord. Okay, so this is a chord. Basically, you have 2 points on the circle and you join them. Okay, you join them, you make a line segment, and that's a chord. Okay, so what we're going to do is we'll draw the right bisector of the chord, and what? The right bisector of the chord has to go through the center of a circle. The right bisector of a chord of circle passes through center of circle. And the next one is just silly, okay? If we have multiple chords and you draw the right bisector of these chords, then they both go, of course, they intersect at the center of the circle. So I'll show you. Really, I mean, if the right bisector of a chord must pass through the center of the circle, then if I draw multiple chords, of course that's true. But I'll do it anyways. That's why I said, really, you could have went straight, like, if the second diagram is true, or the second point I made is true, then this one is just, of course that makes sense. But we'll write it down anyways. Okay, so let's write that down. Right bisector of 2 chords of a circle intersect at the center of a circle. And I can see why the textbook wants us to do it this way, because that's the fourth bullet really pulls the point home. The center of the circle. We're really building the idea. So we go from one right bisector, two right bisectors, and if this is true, guess what? We can have one more beautiful idea here. So this last picture here, last circle, I want to have 3 points here. Okay. So what I'm going to do is I'm going to draw a triangle. Oh, I'm going to draw the chords, I guess you can say. But really, if you connect the 3 points, you're also drawing a triangle. And this is what we said, right? This is what we said in the lesson with the triangle. If you have the right bisector of these three sides of the triangle, which are three chords, guess where the right bisectors have to intersect? Yes, sirree. It has to intersect at the center of the circle. Okay, remember we said that the center of the circle, this is the circumscribed circle, and this is the circumcenter. So I'm not going to draw all that again, because we really talked about this many times already. So I'm just going to jump to the idea we really want. Only one circle can be drawn that passes through, and this is key, 3 non-collinear points. Okay, what does non-collinear mean? That means when you have 3 points, they don't form a line. You can't draw a line that goes through all 3 points, which is clearly the case here. So only one circle can be drawn, which makes sense because there's only one center, right? So you can only draw one circle. But yeah, please make sure these 3 points are non-collinear. And guess what? If these 3 points are on the circle, they're definitely non-collinear. That was a circular argument. Anyways, let's make let's try the first example. So we have points A and B are on the circle x squared plus y squared equals 100. X squared plus y squared equals 100 means that we have a circle of radius 10 and it's centered at the origin. So what we want to do is verify that the right bisector of the chord AB passes through the center of the circle. So this is one of the properties we mentioned earlier, okay? The right bisector of any chord of the circle will pass through the center. So we just have to prove that it's true or verify that it's true. Let's talk about the right bisector of the chord, which means I need to know the midpoint of AB and the slope of AB. So I'll find the midpoint of AB first. Negative 8 plus 0. Beautiful. Nice friendly numbers here. And I'm going to find the slope of AB. So let's see. 10 minus 6. 0 minus negative 8. So that's going to be 4 over 8, which is 1/2. Therefore, the perpendicular slope must be negative 2, okay? Because this is a right bisector. It has to be perpendicular to AB. So since the slope of AB, then my right bisector must have a slope of negative 2. So y equals mx plus b. Let m equal negative 2. Now I'm finding the equation right bisector, by the way. And I'm going to sub in that midpoint of AB, because that's the only point I know of that's on the right bisector. Okay, so I know that the right bisector of chord AB has an equation of y minus 2x. Okay, but my goal is not to find the equation of the right bisector of the chord AB. I have to verify that it passes through the center of the circle. So there's a few ways to do this. So one way is your classic grade 9 way, left side, right side, y minus 2x, sub in 0, 0. So guess what? Left side equals right side. So since left side equals right side, therefore right bisector of, or 0, 0 is on the right bisector of chord AB. And if 0, 0, we already mentioned earlier, 0, 0 is not only the origin, but it's also the center of the circle. Okay, so I've confirmed that the right bisector of the chord passes through the center of the circle. Now, actually, you didn't need to do all this calculation because you know the y-intercept is 0, right? The y-intercept is 0, b is 0, and since b is 0, then of course you can make this conclusion without doing this left side, right side table. 0, 0 is on the right bisector of chord AB because b is equal to 0. So yeah, but you just have to remember what you did in the previous unit with the equation of a circle. You have to remember that this circle is centered at the origin. Okay, so let's check the next one. Find the center of the circle that passes through A, B, and C. Okay, so we already know that if these 3 points are non-collinear, I'm going to give you the hint they are non-collinear. You can prove that by checking the slope of AB and checking the slope of BC, and you'll see that they don't have the same slope. So they are non-collinear. So we can only draw one circle that passes through points A, B, and C. Alright, find the center of that circle though. What's the center of so what we need to do is basically have triangle ABC and find the circumcenter. And the circumcenter is where the right bisectors intersect. So basically you can imagine you have chord AB, chord BC, and chord AC. Instead of side lengths of a triangle, you can think of chords instead. But either way, you have to do pretty lengthy calculations. So we're going to do right bisector of AB, right bisector of BC. Now you might be thinking, what about the right bisector of AC? Well, if I have 2 of the right bisectors, that's good enough to find the circumcenter. You don't need to find all 3. So the midpoint of AB, -2 plus 6, 4 plus -5. Okay, that's going to be 2 and -1/2. The slope of AB is equal to -5 minus 4, 6 minus -2. -9/8. So the perpendicular slope is 8/9. So y equals mx plus b. Let m equals 8/9. Sub in the point, what was it? 2, -1/2. Alright. So -1/2. 2. Oops, it's 8/9 times 2. Okay, be very, very cautious here. If you make a careless mistake here, it's just disastrous. It'll cascade. So this is 16. You know, I'll slow it down. I'm getting a little nervous here. 16. So, oops, that's. Alright, hold on. We want that to be 18. 32/18. Let me just check. 16/9 is the same as 32/18. Yes. Okay. -41/18. That is not the prettiest equation, but it is what it is. Okay. So basically exact same thing one more time. 6 plus -3, -5 plus -4. Okay, we have 3/2, -9/2. What about the slope of BC? Slope of BC is -4 minus -5. Negative 3 minus 6. So that's going to be negative 1 over 9. But we want the slope that's perpendicular because we're working on the right bisector. Alright, so y equals mx plus b. Let m equal 9. That's our slope. And we're going to sub in the point 3 over 2, negative 9 over 2. Okay, let's keep going. Okay, so this will be 27, and then you subtract, so it's negative 9 minus 27, which is negative 36 over 2 is negative 18. 9x minus 18. Okay. Alright, that was a lot of work. And like I said, if you make a careless mistake there, that would be catastrophic. So, now what do I do? Well, I have to solve a linear system. So sub equation 1 into 2. A lot of room for careless mistakes here, so be very careful. Alright, so 9 over x minus 8 over 9. So 9 minus 8 over 9. That's 73 over 9x. And then I'm going to do negative 41 over 18 plus 18. That's 283 over 18. Just let your calculator help you out here. So if you do the math, x is 283 over 146. 283 over 146. Okay, let x equal 283 over 146 for equation 1. That's way cleaner. So y equals 9 times 283 over 146 minus 18. Let's check it out. Negative 81 over 146. Therefore, xy is equal to 283 over 146 minus 81 over 146. Therefore, the center of the circle is at, well, it's a circumcenter, is at 283, 146, negative 81 over 146. Okay, that made me very nervous. There was a lot of things that could have went wrong. So, you know what? We should really check our answer. What we're going to do is check if this is truly if this is truly the center of the circle. The distance from this point, the center, let's say, I don't know, like O, okay? O to A and O to B and O to C must be the exact same distance, okay? Because that is the radius, right? The circumcenter to A, circumcenter to B, circumcenter to C, it has to be the same distance. So you know what? We're going to quickly check that. It's not the prettiest number because this is ugly, but you know what? I can do it. Well, your calculator can do it. So just be calm. Okay. Alright, 6.02. From the center of the circle to point A is 6.02, blah, 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 blah. So let's say 6.02. Beautiful. You know what? I feel great about that ugly answer now. That answer now is my friend. Because the math says so. And you know, if you feel very uncomfortable, take this point and see the distance from point C. And then you'll see it's 6.02 as well. That's the beauty of math. it's the circumcenter, so it must be equidistant to points A, B, and C. All right, so that's the property of circles. You can review the notes, and we're basically done the unit.